Hello, 6th graders. Our next topic we're going to be discussing in this unit is something called ratios. A ratio can be written and explained in a few different ways, and we're going to learn about this in this video. So a ratio can be written a few ways. It can be written as a fraction, it can be written with a colon, or it can be written with the word 2 in between the two numbers. A ratio is a comparison of two numbers by division. That's important to know. A ratio can compare parts to a whole, parts to parts, or two sets, such as number of Miss Strauss's Sharpies to Mrs. Dix's Sharpies. It's a comparison of any two quantities. No matter how large or small, it's meant to compare two quantities. Ratios is used to represent relationships within and between sets. The order of the quantities in a ratio is directly related to the order of the quantities expressed in the relationship. In other words, order matters. Whether the number is larger or smaller first in a ratio, the order in which you put your numbers matters, because that tells us what the exact relationship is between those two numbers. All fractions are ratios, and all ratios are fractions, so they are interchangeable. If you see a fraction, it's a ratio. If you see a ratio, it's a fraction. Ratios may or may not be written in simplest form. So, for example, you may have a ratio like 4:6, or 4:6, or 4:6. And that is not in its simplest form, and that's okay. A ratio can be written three different ways, like I said in the beginning. Fraction form, using a colon, such as this, or using the word 2 in between the two numbers, or like 2 to 3. So let's take a look at a couple of examples using ratios. Example, 7 out of 10 dentists recommend Crest, which is a type of toothpaste. The three different ways to write 7 out of 10 as a ratio is 7:10. Notice how I wrote the number 7 first. That's really important because that is the number that came first in the question. So 7 is going to go first for the next ratio. Another way to write it is 7:10. Or, to write it as a fraction, it would simply be 7 out of 10, or 7/10. Another example is 15 big Post-it notes and 45 little Post-it notes. Look at the ratio when you write it as a fraction. And then, can you simplify it? So if I take the 15, which is the number of big Post-it notes, over the number of little Post-it notes, if I simplify that, that equals 3 nights, which can still be simplified to 1/3. So I'm going to take my simplest form, 1/3, and write it as a ratio, 1:3, or 1:3. So you see, you can take a ratio, like I said up here, is that it may not be written in simplest form, so if that's the case, we have to simplify it before writing it as a ratio. So let's do a couple of practice together. Let's take a look at this screen together. You're going to do some practice on page 14 of your green packet once you're finished watching this video. But here is how this works. Sorry about that. I think I accidentally stopped the video. So I'm going to find the missing numbers in these ratios. So I'm going to first look in this column and look at all of the ratios that are all filled in already. It looks like 6:4 is the only one that's filled in. So if you remember back to rate tables, we want to look for a pattern which is going to help us fill in this ratio table. So if I look in my left-hand column, see all of these numbers, I see a pattern here, either an addition or a multiplication pattern. I see that in the left-hand column, we increase by 3. All the way down. That's a consistent pattern. So I know that this missing integer here is 12 plus 3, which would be 15. And 27 plus 3 is 30. Now, in order to keep a ratio consistent, we need to find a pattern and how to find all of our numbers in the right-hand column. So if you look here, the ratio is 6 to 4. So we need to keep that same relationship the entire way down on our chart. So it looks like there's going to be some sort of pattern to get us from here to here to here to here and to here. My 6 to 4 ratio I could write as a fraction. So basically what I'm trying to find is the missing number here. I know 3 times 2 gets me to 6, so that means what number times 2 can get me to 4? So that means this missing number is 2. Now I have a guess of what my pattern is going to be. I'm guessing it's going to be adding by 2's all the way down, because if I add 2 here, that's 6. If I add 2 here, that's 8, and that makes it 10. That's my guess, but I'm just going to double check to make sure I'm correct. I'm going to erase some of this so I can do some work over here. And I'm going to do the same thing with my next ratio. I'm going to take 6 over 4, written as an improper fraction. Whoops. Equals, my 9 is in the left column, and here is my question mark. So I'm going to find my missing digit here. Gets me from 6 to 9, and then 4 to what equivalent fraction? So it looks like for this, 6/4, another way to write that would be 2/3. Okay, which equals 9 over unknown. It looks like we can't really solve this using fractions because we can't multiply 2 times any number to get us to 9. So I'm not going to use this fraction method to find my equivalent. But what I'm going to look at is my ratios, 6 to 4 and 3 to 2, and I'm going to continue on with this same pattern. And I am going to write here 9 over 6, 12 to 8, 18 to 12, 21 to 14, 24 to 16, 27 to 18, and 30 to 20. So my pattern here is adding by 2 all the way down in the right-hand column. So my ratio table is now filled, even though this looks a little bit messy. That's okay. I paused myself again, so I'm going to wrap up this video shortly. I'm going to do one more example with you in the second ratio table, and then you're going to complete page 14 in your green packet and try some ratio tables on your own. So let's take a look here. 5 to mystery number, 10 to mystery number, and then we have spaces in between. So I'm going to start with 5, and I notice a pattern here. 5 to 10, I can either multiply by 2 or add by 5. 3 spaces down, I see the number 25. So if I try my pattern multiplied by 2, I would get 20, 40. It looks like it's not that pattern because the next number is 25. So this time, I'm going to try adding by 5s and see if it gets me what I need in the left-hand column. So 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20, 20 plus 5, look at that, is 25. So my pattern is to add by 5, so I'm going to fill in my left-hand columns here, all the way down. Perfect. Now I want to fill in my ratios here on the right-hand side. So I'm going to look for, again, another consistent pattern here. I'm going to look at these 4 numbers that are consecutively lined up here. It goes from 18 to 21 to 24 to 27. So it looks like that we're adding by 3. So if I added 3 here, that would be 30, 50 to 30. If I subtracted 5 here, I would get to 13. Oh, sorry, not 5. That should be 3. I was like, why am I not getting the right answer? That should be minus 3, which gets us to 15. Minus 3, minus 3, minus 3, which gets us to 6. Minus 3, which gets us to 3. So 5 to 3, 10 to 6, 15 to 9, 20 to 12, 25 to 15, and etc. all the way down. So keep that in mind as you fill in your ratio tables. Look for patterns, look for the filled in numbers, find that consistent pattern, and then fill in the spaces below as you work. So now is your time to complete page 14 in your green packet if you haven't done so already. If you need to refer back to this video at any time, you are more than welcome to.